Hello everybody. Once again I welcome to the session on formulation of linear programming. So this is my third YouTube video and the first linear programming formulation video. So we'll start the topic straight away. I'll be going to this topic straight away. So what is linear programming first of all? So linear programming is a technique for economic allocation of scarce resources like man, money, machine, material. Okay, so to several competing activities such as product, service, extra on basis of criteria of optimality. So we have to find out the right mix or optimal mix of the quantity. So linear programming is a tool in operation research to identify or allocate scarce resources. Okay, wow. So this is what linear programming is all about. So the full form, so you may hear about this LPP so many times and so many places. So what is LPP? So LPP and the full form of LPP is a linear programming problem. So as I already mentioned, this method helps in achieving the best outcome in a mathematical model. So the best outcome could be either maximum profit or lowest cost. Okay, what? So if you are going for sales revenue, it's a maximization of case, and if you are going for expenses, it's a cost, so you have to minimize ultimately. So that is what do. So where we use this linear programming, basically we use this linear programming in all types of fields, starting from military application, marketing, economics, computer science, mathematics, even in human resources, all types of fields. We can, even in our day-to-day our activities, we can use this linear programming in allocating of resources. Okay, so this is basic. How we can solve a linear programming problem? So before solving a linear programming problem, what we have to do is we have to formulate a linear programming problem. So formulation means nothing. So we are going to form a mathematical model of a given problem. Okay, a problem is taken and we have to formulate into a mathematical model so that it will be helpful for solving a problem. Okay, so what type of problems normally we encounter in linear programming? So normally a diet problem or manufacturing problem, a transportation problem, or optimal assignment problem. So we will see one by one later when we came across this all the problems. Okay, so mathematical formulation. So formulation of LPP refers to translating the real world problem, it may be of any type, in the form of mathematical equation which could be solved. It usually requires a thorough understanding of the problem. So normally it will be given in words or sentences. What we have to do is we have to arrange them or equate in a mathematical form or convert them to mathematical form. Only then we can solve the problem. Okay. So this is the first step in linear programming. You need a LPP problem first of all. Then only we can solve. We have to do a proper, or we have to formulate in a proper way. Then we can solve the problem. So for solving the LPP problem, normally what we do, we use either graphical method or simplex method. Okay, for solving an LPP problem, normally we use a graphical method or a simplex problem. So when we use graphical method, a graphical method can be used only when there are two decision variables. Okay, so if there is more than two decision variables, what we can do, we can go for simplex method. And also we have big M method. Other than simplex method, we can have big M method. So three different methods: graphical method, simplex method, and big M method to solve a problem. But before solving, we have to formulate an LPP. Only then it can be solved properly. So how to formulate? So formulate normally includes four or three different components or three different elements in formulation. General structure of LPP includes decision variables, which you call it as x1, x2, x3 up to xn. So based upon the number of products or the decision on what we have to take. Suppose if we want to take about the products we have to manufacture on x1, how much units of x1 we have to manufacture, how many units of x2 we have to manufacture, and how many units of x3 we have to manufacture. Based upon that, we will decide. So that is what decision variables. And second important thing is objective. As I already mentioned, there are two important objectives: either to maximize our profit or minimize our cost. In a linear programming, these may be the two important objectives. Okay, this is our objective or aim, what we have to achieve. And the third important thing is we have to formulate the constraints which we have to satisfy in order to achieve our objective. There are some constraints, there are some limitations will be there. Based upon that, we will formulate the objectives. Otherwise, it's going to be a problem. So constraints has to be satisfied. And one more thing which is not given here is non-negativity constraint. So a non-negativity constraint has to be mentioned in the linear programming problem so that the complete formulation is completed. Okay, so there are four important components as we discussed now. First one is decision variables, and second one is objective function, third one is constraints, and fourth one is non-negativity constraint. Okay, wow. So non-negativity terms, or what are the non-negative variables, called as non-negative variables. Okay, so there are four important steps in order to formulate this linear programming. What are the four important steps? The first step is we have to identify the number of decision variables. So the number of decision variables means, for example, how many number of decisions you have to take. So variables may be, you can give it as x1, x2, x3, x4, up to xn, based upon which the numbers is going to be there. Okay, so based upon the number of respondents, based upon the number of decisions on which the variables has to be taken, we can decide how many number of variables. So n number of variables, n number of x's will be there. The second step is to identify the constraints. So constraints, you call it as limitations. For each and every constraint or each and every decision variables, they have to explain in the linear form. Okay, so the conditions will be there. So we have to satisfy the conditions. Then the third important thing is the objective function. So we have to express the objective function in the form of linear equation. Okay, well, we can form it in the linear equation. And the fourth step is we have to mention the non-negativity constraint. Okay, so and the fifth step is we have to optimize the objective. Here it was mentioned as fourth step. After mentioning the non-negativity constraint, the formulation is over. Okay, the formulation starts with identifying number of decision variables, identifying the set of constraints, and expressing the objective function. And next one is writing the non-negativity constraint. So after doing all these four, that is decision variable, constraint, objective function, and non-negative function. These four are the most important thing in a mathematical formulation. Okay, once you formulate, the fifth step is you have to optimize the objective function either graphically or mathematically. I have told you there are methods to solve the problem. So here it is mentioned as 4, take it as fifth one. So it is optimizing the objective function, that is solving the function either graphically or mathematically. So if you go for mathematically, the methods are none other than simplex method as well as big M method. Okay, so in every formulation, so I will show you two cases. As I mentioned, there may be two important types of objective. One is your maximization and another one is minimization. I will show you two examples in this session. Okay, one is of maximization type, another one is of minimization case. Okay, so both these solved examples, I have taken it from N.D. Vora, Quantitative Techniques by N.D. Vora. Okay, so courtesy for that particular book. So this is a solved problem from that particular textbook. Okay, if you want, you can refer that book. It is Quantitative Techniques in Management by N.D. Vora. It's a 6th edition, is also updated now. So you can use the textbook, which is very well explained with all the examples. This is an explained model. So here it is, the first one is of maximization. As I explained, there are two types of cases. One is maximization, another one is minimization. This is the first type. The first type is of maximization case. Okay, a firm is engaged in producing two products, A and B. Each unit of A requires 2 kg of raw materials and 4 labor hours of processing, whereas each unit of B requires 3 kg of raw materials and 3 hours of labor of the same type. Every week the firm has availability of 60 kg of raw material and 96 labor hours. So all these are constraints. Okay, 1 unit of product A yield. So note this word, so yield rupees 40, and 1 unit of product B sold gives rupees 35 as profit. Which means, so this last line you can note, 1 unit of product A sold rupees 40, yields 40, and 1 unit of product B sold is this one you can take it as a objective function. Okay, well, so as I mentioned here, so we can write the problem, the given statement in a problem mathematical form, which is maximize Z is equal to 40 rupees 40 of first unit A and 35 of second unit. Okay, so 35 x2. Subject to constraints. There we have two different constraints. One is raw material constraint and labor hour constraint. Okay, so you can also include these two constraints. The first raw material constraint. So if you take the raw material constraint, that is product A requires 2 kg of raw materials and product B requires 3 kg of raw materials. So 2x1 plus 3x2, and the total raw material available is only 60. That's why given less than or equal to. So please note down, these symbols are very, very important. In maximization case, most often it will be less than or equal to 60. Similarly, 4x1 plus 3x2, which is labor constraint, which your availability of total labor hour is 96. So two constraints, one objective function, and the last one is non-negativity restrictions. Okay, so both excuse me, your x1 and x2 must be greater than or equal to, which means no negative values are allowed here. So when you decide how many units of x1 you have to produce and how many units of x2, it must be of positive nature. Okay, so that's why it is given as x1 and x2 greater than or equal to 0. So here, as I mentioned, x1 is one decision variable, x2 is another decision variable. So two decision variables. This is the first one. Second one is this constraint. Okay, and the third one is this objective function, and fourth one is this non-negativity constraints. Okay, so all these four components are very, very important. So first you write what are the decision variables. Second, you decide the objective function. Okay, third, you write the constraints, and fourth, you go for non-negativity restriction. This is the basic thing you have to do it in formulation of linear programming. Similarly, one more example I have taken again from the same textbook ND Vora. It is of minimization case. So here also you can see there are four important components. The first one is decision variables x1 and x2. The second one is objective function. Objective function here, since it is cost, okay, so since it is cost, it is minimization case. Since it is cost minimization case, we have to know z is equal to 40x1 plus 2x2, which is of cost nature. That's why it is minimization case. And you can note down the changes in the equality sign. Here it is greater than or equal to. Okay, so here we have more than what is available. So which is phosphate, one is phosphate constraint, another one is nitrogen constraint. So two constraints were available, and similarly non-negativity constraint. So here again two decision variables, one objective function, two constraints, and the last one is non-negativity constraint. Okay, well, so these are the basic things you have to follow while going for formulating of linear programming. Okay, so this is very short video of how to formulate this linear programming. A detailed description you can follow any textbook, specifically ND Vora Quantitative Techniques in Management 6th edition is available. You can just follow that book. It's explained very clearly. Okay, so a formulation is nothing but mathematical expression of given statement for solving a problem. Okay, so that formulation has to have four different steps. One is decision variables has to be decided. Second one is objective function. Third one is you have to develop the constraint. Fourth one is you have to write or mention the non-negativity constraint. Hope you like this video. Okay, so you can see all these details, and if you like this video, thank you very much for patiently.